Hello and welcome back to NorCal 715. So, about a month ago or so, a customer sent me this power supply board to be tested, and some of the commenters asked me why I didn't ESR the capacitors on it. So, I'm going to go ahead and do that now. We'll ESR all the caps, find out their values, see if they're okay or not. Plus, I've made this dummy load assembly with a bunch of resistors I ordered online. And what this is a heat sink off of an old Allen Bradley drive that's no longer used anymore. So it's got some pretty deep fins on it. And so I took it and I milled all the protrusions across and made it completely flat. And then I mounted these different value resistors on here. So what I'm going to do is test this power supply at 100% of its rated output. So we're going to load this thing to the 5 volt standby at 1 amp, the 5 volt run at 3 amps, the 24 volts at 8 amps, and the 12 volts at 1 amp. So what I've got is a bunch of little single pole, single throw switches. And I'm going to take and solder these switches to the ends of all the resistors and create a common ground bus so that when I switch the switch to on, it's going to cause the resistor to load and draw that amount of current. So the highest load we're going to have is on the 12 ohm resistors with 24 volts across them. It's going to be 2 amps per resistor. I ordered 100 watt resistors for the 24 volt power supply, and they're going to be dissipating about 48 watts a piece. And then the other resistors are well under their rated value. I've got the 5 ohm 25 watts and the 10 ohm 25 watts, as well as the 6 ohm 50 watt resistors here. So I'm going to go ahead and wire that up real quick. So I'm just going to start by pre-tinning the ends of each resistor to accept the switch. I'm going to tin the switch. Just going to heat both of them up. Get them to bond. And then we'll go ahead and add all the rest of the switches. And I'm going to add a common negative bus to all of this to go back to the power supply. Alright, so I've got all the switches added now, and I've got one common ground bus bar. I'm going to add the chassis ground on the power supply board, so that way I can switch each load on individually here. And I use a piece of a solid 12 gauge wire so it will support the switches. That way I can turn them on and off as necessary. So like in my previous videos, I went ahead and marked all the capacitors. I'm going to unsolder and we'll ESR all of these. So let's get them unsoldered. And I generally wiggle the solder sucker to make sure I get all the solder all the way around the lead. That's why you see the board shaking while I'm desoldering. And that just makes sure, don't know if you can see it, but the lead's moving up and down. I want to make sure it's completely free of the circuit board. So the reason I only unsolder the positive leads is if there is a inductor like there sometimes is in a pi filter, not in this case, but there's a capacitor and an inductor and then another capacitor. If I don't unsolder one of the positive leads, the inductor can actually create a higher ESR reading on the meter than just shorting leads together. And I'll try to show that. There's an inductor right here, and I'll try to measure across this inductor and see if we get 0 ohms or less than 0 ohms. So it looks like I got them all. Now I'm not going to unsolder the main power filter because that's a single capacitor. There's no other capacitors in that circuit. So we'll test that one still soldered into the board. So I've got my ESR meter. Now short the leads together and make sure I'm at 0. So checking this inductor right here reveals that it's much less inductance than I expected. So I'm going to use this power transformer. So first, I'm going to zero my leads, and they're at 0. But if I check this lead right here, it's past 0. So that can skew the readings. That's why I unsolder the positive leads. And especially here, you've got 3 capacitors in parallel. So what I want to do is check the pad and make sure I'm at 0. Then if I check each individual capacitor, and I can make sure I'm at 0 ohms and a 1000 microfarad capacitor. So let's just go up the line and we'll check all these guys. 0. Check the pad. No resistance. That's good. Another 1000. 20, 30 ohms on the pad, but the capacitor itself is 0. Oops, I drew the circle in the wrong place. Pad is 0. Capacitor is 0. That one's good. Pad is 0. Capacitor is 0. That's good. 4.7. I expect to see probably between 4 and 10 ohms on this one. So a pad is 0. Capacitor is right at 10 ohms. 22. Pad is 0. Capacitor is about half an ohm. That's good. Another 22. Let's look at the pad. About 25 ohms. The capacitor itself is 1.5. That's very good. So this is a 100. I'll look at the pad first. 0. And the capacitor is about almost 6 ohms. I'm suspect of that one. So I'm going to draw a second circle around it. So I want to change that one. Now these down here are 10 microfarads. So look at the pad first, 0. Wow, the capacitor is pretty close to 100 ohms. That one's bad. Pad 0, capacitor about 60 ohms. So I want to change those two as well. Draw another circle around those. So before I do anything, let's check this main filter cap. That one's good. I think that's probably a 470. 390 microfarad capacitor. So I'm perfectly happy it's close to 0. So the only ones I found that were really bad were these 2 10s and a 100. So before I change those, I want to go ahead and hook up the dummy load and test it previous to changing those and see what kind of results we get. So let's go ahead and hook that up. Okay, so hopefully you can see the voltmeter here. If I get the glare off of it. Now I've got this connected to my isolated variac. It's a Syncor PR57. I left that in the comments of the last video. Okay, so I've got everything connected. Hopefully you can see the meter okay. Now I've got this plugged in. Here's the AC line cord going into it. And it's connected to my Syncor PR57, which is an isolated variac. It's a variable AC transformer with a isolation transformer built into it. So this is completely floating from the AC line and the neutral. So these switches are connected. This is the 5 volt standby power supply going through 10 ohm resistors. So to get 1 amp, I need to switch both of these on. This is the 5 volt run power supply. These are 5 ohm resistors. Now to get 3 amps, I need to switch on 3 of these. This is the 12 volt 2 amp supply going through 6 ohm resistors. So each resistor is going to draw 2 amps. This is the 24 volt 8 amp power supply. So I need to switch on 4 of these to get 8 amps at 24 volts. Everything's off right now. Now this one switch that's lone right here is the standby power supply on command. So this turns on the power supply, the main run power supply. So now that everything's off, with the exception of a half amp load on the 5 volt standby power supply, let's measure the voltages. So this is the 5 volt run power supply, 5.267 volts. This is the 12 volt run power supply, 12.03 volts. And this is the 24 volt run power supply, 24.24 volts. So let's incrementally turn these on. So I'll put my probe on here, 5.2 volts. So there's 1 amp, 2 amps. There's a 3 amp draw on it. So let's look at the 12 volt power supply. Now one of these is going to be 2 amp load, 11.6 volts. Now this is the 24 volt run power supply. So we're going to turn 4 switches on. That one was already on. So 2 amps, 4 amps, 6 amps, 8 amps. Will it do 10? Yes, it will. It'll do 10 amps. So the power supply right now is fully loaded with the exception of the 5-volt standby power supply. So it's running right now. So let's turn that on. And it continues to run, no problem. So we've got 8 amps at 24 volts, 2 amps at 12 volts, 3 amps at 5 volts, and 1 amp at 5 volts on the standby power supply. So let's go ahead and change those power factor correction capacitors and see if that makes any difference. Okay, so I've got my power on. I'm connected to my Variac with an isolation transformer, my Sencor PR57. And so this switch right here is what turns the power supply on. Here, click. So right now the 5-volt standby power supply is at 4.786. Now I've got one of the 10 ohm resistors on, which is giving it a 1/2 amp load. And I haven't turned the full 1 amp load on yet on the standby, so we'll go ahead and turn that on. Brings down to 4.671 volts. And so right now on my run power supplies, I should have 0 on all of them. And I do. So let's go ahead and unload it. I'll switch the main power supply on. So I should have voltage on my run power supplies now. 5.2, 11.4, and this should be 24 volts, 25.9. So let's go ahead and load all these things up. So we'll give it a little bit at a time. So right now I'm loaded at 12 volts at 2 amps, 11.8. I've got 5 volts at 1 amp through one 5 ohm resistor, 5.2 volts, and I've got 48 volts at 2 amps through one 12 ohm resistor. So let's ramp it up. So now I've got 24 volts at 4 amps, 24.8 volts. I don't know if the 12 volt can handle 4 amps. It's not rated at 4, but yes, it can. 5 volts is now at 2 amps. So let's go to full beans on the 5 volt power supply. That's 5 volts at 3 amps, 5.1 volts. And we'll go full beans on the 24 volt power supply. So it's loaded at 8 amps right now, 24.64 volts. The 12 volt circuit is 11.78 and the 5 volt run circuit is 5.08. Now the 5 volt standby is 4.8 volts. So what I'm going to do is, I didn't order enough resistors to load the 12 volt power supply to 1 amp, so we're just going to leave the one on. But I'm going to turn off 2 of these on the 24 volt power supply, and we'll turn off 1 of these on the 5 volt power supply. And we're just going to let this sit here and cook for a while. Now you may have noticed I added this black tape on here because I'm going to grab the infrared camera and measure the temperature on the heatsink as well as the individual resistors. And since the aluminum does not emit heat very good, it's a very good conductor of heat, but it's a very low emitter of heat. The emissivity is very low on it. Now, black electrical tape has a very high emissivity rating, so it emits heat that the camera can see. When I get the camera, I'll show you the difference between the heatsink where I have the black tape on it and the heatsink where there is no black tape. So I'm going to let this run for a little bit and come back in a few minutes. We'll grab the camera and hook it up, and we'll look at some temperatures of both the power supply board and of the heatsink with the resistors. Okay, so here we are with the infrared camera going, and here's what I was talking about with the heatsink minus the tape. Right here it's saying 83 degrees, but if I look where the tape is, it's saying 105 degrees. So here I've had the power supply running down here. It's just sitting on the floor running. Been going now for probably about 4 hours. And I still have that 4 amp load on the 24. And I have a 2 amp load on the 5 volt. The 5 volt standby is loaded at 1 amp. And the 12 volt run is loaded at 2 amps. So you can see these two top resistors are very hot, 150 degrees. I have a fan sitting up back here, you can see it running. Keep keeping the heatsink cool. Main transformer is very warm, 158 degrees. So I think at this point I can say without a shadow of a doubt this board is in good condition. I'm going to send it back to the customer at this point. If this video has helped you, please consider making a donation on my YouTube homepage with the PayPal donate button or at paypal.me/NorCal715. With your help, we can keep these things out of the landfill and out of the recycle bin. Everybody have a great day. Thanks for watching. Bye-bye.